Yes, our topic is vector. This is our topic.
I wanted to do
Yes,
start with mechanics today.
yeah, that is a mechanics part. Okay,
Oh, okay.
okay. So we were study the first thing, first chapter of the mechanics. That is what you saying me uh, as a syllabus. It is mentions that the first thing that will start from vector. Otherwise, we are not moving to the. You can see the next chapter, which is. mm, the Newton's law and all other things.
Oh, you mean you want to do motions first?
Yeah.
Motions and then
Yes.
force.
Forces. So the thing is that you know about the scalar. So what do you mean by scalar? What do you know about the scalar? That means you know that I think that scalar quantity is uh, only have magnitude but no directions. That we know that the basic definition of you can say a scalar quantity is that a scalar quantity you can say is defined as a you can say physical quantity having you can say only magnitude having only magnitude but no direction. That is the basic definition of scalar. And you know that there are some physical quantity like you can say length, mass, time, energy, temperature that are fully described by their magnitude. So that is called as a scalar. And the basic definitions of vector is you know that a vector quantity is defined as a physical quantity having both magnitude and directions. So we know that a vector quantity you know that is defined as a physical quantity having both magnitude and directions having both magnitude and you can say directions. Now the thing is that so you know that there is you can say displacement or you can say velocity or accelerations that are treated as a vector quantity. But the thing is that can you tell me whether this current is vector or scalar? Current is vector or scalar? What do you think?
Scalar.
Why? Because it has a magnitude and as well as directions. So
It has no direction.
why? Because it has the directions. Because we know that when we define some resistors and we are giving some battery, a current will be flowing in this particular directions.
Oh, okay. So
Okay.
it's like
So the thing is that there makes a confusions that the thing is that mm, so it is scalar, but though the definition suggests that a vector quantity is nothing but a physical quantity having both magnitude and directions. So the thing how you can be explained. That means what we actually go through in our class 10. That means the vector means it has only magnitude and directions. It is not the whole thing that you should know. That means the vectors should follow some vector algebra. Vector should follow some vector algebra. What is the problem of this current? That current will the you can say the current will follow there is a law that is called Kirchhoff's law. Kirchhoff's law. But in case of if it is should be a vector, vector means it has magnitude, it has magnitude, it has directions, and as well as it follows, you can say, vector algebra. It should follow the vector algebra. So the thing is that that is the main thing that you should know. That means you know a vector is represented by a, you can name any letter, and we are representing it by some arrow. In some books it is represented, you can say, with bold, but the thing is that it is we are representing it by using a arrow sign. So that means what will happen if we consider, you can say, if we consider a two-dimensional, say this is the x-axis and this is the y-axis, then if we want to find, this is called, this is a particular point, and this nothing but is known as, this r is known as position vector. This is known as position vector. That means if this point is denoted by x and y, so what we can write, we know that the x-axis should be represented by some unit vector and y-axis should be represented by some unit vector. So we will discuss this later. Okay, the thing is that this unit vector definitions and all vectors definition should be given like that. You can say that this I cap and this j cap, that are called unit vector. Unit vector means whose magnitude is unity, whose magnitude is unity, but it has some directions. That means you can say I cap is nothing but it is a unit vector and along, you can say, x directions, along x direction, and j cap, that is the unit vector along y directions. And this, if there is another, say, axis, say z axis, then there is also some unit vector that is fixed, that is k cap, that is unit vector, you can say, along z directions, along z directions. So that is the corresponding unit vector. Unit vector means whose magnitude is 1, but the thing is it has particular directions. It has particular directions. So when you write this position vector, say we are writing this position vector in 3 dimensions. So this r can be written as I cap x, j cap y, and k cap z. That means this is the unit vector along x-axis, this is the unit vector along y-axis, this is the unit vector along z-axis. Now if we consider the magnitude of that, then what we can say, the magnitude is nothing but x square plus y square plus j square. That is the corresponding magnitude of r. This is the magnitude. And this unit vector definition, we can say, if we write r cap, this is nothing but unit vector. This, the definition is the vector divided by its magnitude, that can be written as a unit vector. That means any vector divided by its magnitude can be treated as a unit vector, and unit vector means the magnitude is 1, unity, and it has some directions. Now if we say, if we draw the diagram like that, say, you can say like that, this is the, we are considering only, say, x y z axis, whatever be the thing, x y z axis. Say initially the particle at some point p1, and finally it moves to some point that is a p2. So what will happen, the position vector of p1 is r1 and the position vector of p2 is r2. Now if we want to find this particular, that means this is the directions, if we want to find this particular directions, that is called, you can say, del r. then actually what we can write in vector additions rule, this r1 should be added with del r, that can be given by r2. That means the value of del r that actually called the displacement vector, that is known as, you can say, displacement vector, and that is nothing but r2 minus r1. And r2 is nothing but, you can say, if the coordinate of r2, say this is x2, this is y2 and z2, and this is x1, this is y1 and this is z1, then we know that r can be written as like that, ix plus j cap y plus k cap z. So what we can write, I cap, this is x2 plus j cap y2 plus k cap z2, that is minus with I1, that means I cap x1 plus j cap y1 plus k cap z1. And if we take common I cap, then it should be x2 minus x1 plus j cap y2 minus y1 plus k cap, this is z2 minus z1. So the thing is that, so what should be the magnitude? If we write r is I cap x j cap y plus k cap z, and if we consider the magnitude of r, that should be x square plus y square plus z square. So if we consider the magnitude of del r, that can be written like that, that x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So that is called nothing but the displacement vector. That is called displacement vector. Now the thing is, that particular formula that we derive, that is nothing but, you can say, the laws of vector additions. What I am saying, that apart from that a vector should have some magnitude and as well as directions, it should follow some vectors algebra. So what is a vector algebra? That means it obeys the laws of, you can say, vector additions. Laws of vector, you can say, additions. And the thing is that in case of laws of vector additions, the first law that we can say, this is nothing but triangle law of vector addition. The triangle law of vector addition. And that is one of the important thing. You just see, if this is a r1, this is a del r, and this is a r2, we can say that r1 plus del r can be written as r2. What does it mean? If we write it in a form of law, what we can say, that it states that if, you can say, two vectors, if two vectors can be, if two vectors can be represented in, you can say, magnitude and directions, magnitude and directions by the, you can say, two sides, magnitude and directions by the two sides of a triangle. So you can just say, you just see, this is nothing but r1 is a one side of the triangle and del r can be represented as another side of the triangle. So what I am saying, that if two vectors can be represented, can be presented in magnitude and direction by the two sides of a triangle, taken in the same order, taken in the, you can say, same order, then what we can say, then the resultant, then the resultant is, you can say, represented, resultant is represented completely, represented completely in, you can say, both in magnitude and directions, magnitude and directions by the third side, by the third side of the, you can say, triangle, taken in opposite order, that taken in opposite order. What does it mean? That means when we are just adding scalar quantity, that means we are adding 5 with 6. We are just adding and we will get the result. But the vector additions is not like that. That means if we want to add two vectors, that means the first vector should be represented is a side with the triangle, another vector say represented with the side of another triangle in the same order, then the resultant is represented completely by a third side of the triangle but taken in opposite order. If this happens, then only you can say the value of c can be written as a plus b. So that is the laws of vectors additions. So this is the triangle law, that is the triangle law. But the thing is that there is also another law, that you can say the parallelogram law of vector additions. And in case of parallelogram of law of vector additions, you can say there is also some analytical methods by which you can find the value. Like that, when we are dealing with the triangle law of vector additions, uh, because we are finding c equals to a plus b. Now if we want to find that what should be the magnitude of the resultant, we have to find you can say the magnitude of the resultant, just by using triangle law of vector additions. So what we can say this is the corresponding triangle. Say we are saying that this is the corresponding triangle. Say this is represented by a vector p, this is represented by a vector q, and that is in opposite side, that is the resultant r. And say the triangle is a, this is b, and this is c, and say this angle is beta, and this, if we extend it, this is theta. So what I am saying, that from the point c we are drawing, you can say perpendicular, that is you can say perpendicular to ab, that is meeting ab at point e, and this is 90 degrees, and that is a theta. And the angle, this cbe is nothing but theta. If you not understand, you just raise me that, because that is one of the important thing, and that would be, you can say, that would be disturbed you throughout your syllabus, class 11, 12, whatever. In electrostatic also, you have to know the vectors additions. So if something is problematic, just tell me that it is not clear. Okay. So the thing is that this, from this right angle triangle AEC, from, you can say, we have to find the magnitude of this r. The main thing is that you have to find the magnitude, and as well as the magnitude of the resultant, and as well as the directions. That means we know that vector r should be equals to vector a plus b, but what should be the magnitude of this r, and what should be the directions of the r, then you can find this particular formula. So we have to derive the formula, that you know that from this right angle triangle, right angle, you can say, triangle. So the right angle triangle is AEC. That means this is A, that is AE, and C. That means this triangle. So if we consider this particular triangle, what we can find, that is the hypotenuse. That means AC square can be written as AE square, can be written as AE square plus EC square. And what is AE? AE can be break into two parts. One is, you can say, AB, and one is BE. So AB plus BE whole square plus EC square. So what we can write, that, so this is AB square plus BE square plus 2AB plus into BE plus AC square. So this is nothing but, you can say, AC square. Now from that particular figure, what we can see, if we consider this triangle, that means this triangle you can say, if we consider the triangle BEC, then from that triangle what we can get, that BC square can be written as BE square plus EC square. You can write like that. So from that what we can get, because in that particular figure this is a BE square and this is EC square, so if we add this, what we can get, that AC square is equals to AB square plus BC square plus 2AB into B. We can write like that. And if we consider this triangle from BEC, what we can write, the value of cos theta, you can write this is nothing but BE by BC, because value of cos theta, this is a theta. If we take this particular triangle, then the cos theta is nothing but this BE by this BC. So what we can find, because we have to know the value of BE, so BE is nothing but BC cos theta. So we can put this value, that means AB square plus BC square plus this is 2AB and this is BE. BE means it's nothing but BC cos theta. And so from that figure what we know, that the value of AB is nothing but P, the value of BC is nothing but Q, and the value of AC is taken as R. So what we can write, that R square can be written as, this is A square, that is you can say that is P square, that is Q square, and this is nothing but 2, this is P into Q into cos theta. So that is, you can say, the resultant of R. That means R can be written as root over P square plus Q square plus 2PQ cos theta. That is nothing but, you can say, the resultant of this two vector. So read, it is clear?
Yes, sir.
Okay. And since you are already in your class, electrostatic is going on, right? So in electrostatic, you will also follow this formula when you are finding an electric field, or you are not come across this particular formula.
I think I bumped into it. Yeah.
Okay. Now the thing is that there is another thing that you have to know, that what should be the directions of the resultant, because this is the corresponding resultant, and if we find the directions, that means that will make an angle beta. So if we say that, suppose your resultant R that makes an angle beta with the directions of the vector P, that means we are taking that, suppose that, you can say, the resultant, this R that actually makes an angle beta, you can say, with the directions of vector P. So from the right angle what we can get, that the value of tan beta, you can write tan beta means it can be represented by, you can say, CE, that means this one, CE by, that should be equals to AE. That means if we say it like that, that should be, tan beta is nothing but, this is a CE and divided by, that is AE. So you can say that tan beta is nothing but CE divided by AE, and this is CE, and AE can be written as, you can see, it can be, this is totally AE, so it can be break into two parts, one is AB and one is BE. So you can say it can be written as AB plus BE, and you know the value of AB is nothing but P, and you already found that the value of B is nothing but BC cos theta. So BE is equals to, you can say, BC cos theta. So you have to find the value of CE. So if we consider this particular triangle, CBE, so if we consider sine theta, then if we sine theta is this, sine theta is nothing but, you can say, that can be CE by BC. So what we can write, that CE is equals to BC sine theta. C equals to BC sine theta. So we will get that CE is also BC sine theta, and BC means nothing but Q. So this is Q cos theta and this is Q sine theta. Now if you put this particular value, that means this is Q sine theta, and that is, you can say, P plus Q cos theta. So that is also one of the important formula in vector that will be helpful in other mechanics part, that the directions, if we want to find the directions of two vectors, that the directions can be represented by tan beta, which is nothing but Q sine theta by P plus Q cos theta. So that is one of the important thing. And uh, you can say that is also the same law, but this is the triangle law, but there is also another law which actually did the same thing. That means additions of two vectors, that is called, you can say, the parallelogram law of vector additions, that will give you the same result, that is called parallelogram, you can say, law of vector vector additions. So the thing is that, so in fact what we know, that the parallelogram law of vector additions, that is another way of stating the triangle law of vector additions. This is nothing but, in fact, what we can say, that the parallelogram, you can say, law of vector addition, you can say, another another way of, you can say, stating the triangle law of vector addition, another way of triangle law of vector addition. And it also states the same thing but in different way. That means it states that, you can say, if two vectors, you can say, acting simultaneously, if two vectors acting simultaneously at a point can be represented can be represented both in magnitude and, say, directions by the by the two adjacent sides of a parallelogram. The resultant is represented completely by the diagonal of the parallelogram. That means in that particular case, in triangle law, that is represented by another side of the triangle in opposite order. But in that particular case, if we, you can say, if we represent the vector like that, if we represent this vector as a side of the parallelogram, one is P, say one of the Q, then if you complete this parallelogram, then what I am saying, the diagonal of this, that will represent the additions of this vector. That means diagonal can be represented at P plus Q. So it states that if two vectors acting simultaneously at a point can be represented both in magnitude and direction by the two adjacent sides of a parallelogram, then what I am saying, then the resultant, then the, you can say, the resultant, that is represented, the resultant is represented, you can say, completely by the, you can say, diagonal completely by the diagonal of the parallelogram passing through that point, passing through that point. That is the same thing. That means if you want to find the result of that, or you can prove the thing, you will get the same thing. That means you will get the same thing. That means in that case also the resultant is can be represented by p square plus q square plus 2pq cos theta. You can say, and you can say this theta is this angle and beta is this particular angle, and of course the tan beta is nothing but q sine theta. This is q sine theta divided by p plus q cos theta. So that is nothing but the resultant, and that is nothing but the angle. Angle is what? This is the angle between this p and the resultant. Okay. So but the thing is that what we are discussing, that means the vector additions, that is we are additions of two vectors. But the thing is that if there are more than two vectors, if there are more than two vectors, because in the triangle law and in the parallelogram law what we find, that we are dealing with the vector additions but only for two vectors. But the thing is that what if that resultant of more than two vectors? So that law, that is the third law, that is called, you can say, the polygon law of, you can say, vector addition. The polygon law of vector additions. And this law actually helps us to obtain the resultant of more than two vectors. And this law is just the extension of the triangle law. That means it states that this particular law, it states that if a, you can say, number of, if the number of vectors, you can say, can be represented, if the number of vector can be represented in, you can say, represented in magnitude and direction by the sides of, you can say, sides of a polygon taken in the same order, then their resultant is represented, then their, you can say, resultant, then their resultant is, you can say, represented in magnitude and, you can say, direction by the closing side of the polygon, by the closing side of the polygon taken in opposite order, taken in opposite order. What does it mean? That means they are given that there are vector a, there are vector b, there are vector c, there are vector d. You have to add these four vectors. Then what your law says, that you have to represent first side of the polygon by a, then this side is the polygon b, then this side would be polygon c, this is the side of polygon d. Then the vector which is in opposite order, that will actually give the resultant, and this is nothing but a plus b plus c plus d. So that is the, you can say, polygon law. So by using the polygon law, what we can do, we can add actually more than two vectors, we can add more than two vectors. So actually the triangle law and the parallelogram law that are used for adding the vectors, but not more than two, that will add two vectors. But in case of polygon, it will actually add more than two vectors. So the resultant would be like that. And there is one of the important thing in vector that is called scalar product, that will be helpful when we are dealing with lots of problems, when you are dealing with electrostatics or whether you are dealing with work. That is one of the important thing that is called, you can say, the you can say the scalar product. This is called the scalar product, or you can say, or dot product, the scalar product, or you can say dot product of two vector, of two vector. That is the notation that we use to solve different problems. So you can say the scalar product or dot product of two vectors, that is defined as the product of the magnitude of two vectors and cosine of the angle between the two vectors. What I am saying? That means the scalar product or dot product of two vectors, that is, you can say, that is defined as the, you can say, defined as the product of the magnitude of two vectors, magnitude of two vectors, and you can say the cosine of the angle between the two vectors, between the two vectors. What does it mean? That means if we are define a dot b, that means it is nothing but the magnitude of a, the magnitude of b, and cos theta. That is the corresponding formula. That means a dot b is represented by magnitude of a, magnitude of b into cos theta. Now the thing is that what we know, that we know I cap is a unit vector, you know, along x axis. J cap is a unit vector that is along y axis, and k cap is a unit vector that is along z axis. Now the thing is that means x axis is perpendicular to y, as well as y is also perpendicular to z, as well as z is perpendicular to x. Now what we will find, if we find I cap dot I j cap, then what will happen? You will just put this into formula. This is the magnitude of I cap, this is the magnitude of j cap, and the angle between this is nothing but 90 degree, and cos 90 is 0. So the thing is that I dot j cap, the value is 0. That you should remember, because to solve different problems, or you can say, if we write j cap dot k cap, or if you can write j cap dot I cap, in both cases, that means I cap plus j cap, or j cap dot k cap, or k cap dot I cap, and whatever be the thing, that means you can write j cap dot I cap, as well as you can write k cap dot j cap, whatever be the thing, if they are perpendicular to each other, the value is 0. Now if we consider I cap dot I cap, then means I cap dot I cap means two vectors are in same directions, that means the angle between these two is 0. Then what we can say, I cap magnitude, then I cap magnitude, and the angle between this is cos 0. So you know that is a unit vector. What do you mean by unit vector? I told earlier that unit vector means whose magnitude is 1, unity. That means this magnitude is 1, I cap this magnitude is also 1, and the cos 0 the value is also 1. So the result is 1. Similarly, if we do j cap dot j cap, if we do k cap dot k cap, that should be equals to 1. So I think, is it clear?
Yes, sir.
Okay. So the thing is that if we say a vector is represented by that, say ax is the magnitude I cap, then ay this is j cap, then az this is k cap, and b is a vector that is represented by bx I cap plus by j cap plus bz k cap. Now if we do a dot b, then what will happen? You just see, we are writing like that, a cap I cap plus ay j cap plus az k cap. This will be dot with bx I cap plus by j cap plus bz k cap. Now what we know, that I cap dot I cap is 1, j cap dot j cap is 1, and k cap dot k cap is 1, and the rest all the thing are 0. That means the result you can write that ax with multiplied by this, that means ax bx, ay by, and az and bz, because I cap dot I cap is 1, j cap dot j cap is 1, and k cap dot k cap is 1, and all the rest of thing, that means I cap dot j cap, I cap dot k cap is 0, or j cap dot I cap is 0, j cap dot k cap is 0, k cap dot I cap is 0, and k cap dot j cap is also 0. Then what you are finding, you just see the thing, that is a vector. That means a is vector, a is vector, b is also vector, but the result that we got is a scalar. So that's why this is known as a scalar product. That means we are doing dot product of two vectors, but actually the result that we get is nothing but a scalar. That is the main thing that we should know about the thing. Now there is another term in vector that will be helpful when we are dealing with an electrostatic. There is torque, the quantity is torque, or in your mechanics part you will also see the quantity that is torque, and that can be represented by a vector that is called vector product, that is a scalar product, and another product that is called vector product, or you can say cross product, that is nothing but cross product of two vectors. Cross product of two vectors. What does it mean? That means is a vector having magnitude equal to the product of the magnitude of two vectors and the sine of the angle between their directions. In the previous class, that is the cosine angle between these two vectors, but in that particular case this is the sine angle. That means, what do you mean by vector product or cross product of, you can say, two vectors, of two vectors, you can say is a vector, you can say having, you can say magnitude, having magnitude equal to the, you can say, product of the magnitude, product of the magnitude of the two vectors and the, you can say, sine of the angle between their directions. Between, you can then sine of the product of the magnitude of the two vectors and the sine of the angle between their directions, between their directions. And since it is the vector product, the result is scalar. That means it has no directions. But since the result of two vector is itself vector for the vector product, so it has a directions. So a directions, and this particular directions, you can say, that is, you can say, perpendicular, that is perpendicular to the plane, perpendicular to the plane, that is containing the vectors. So vector product, that you can say, if C is a vector product, we can write this is A cross B, we can write like that, and it is nothing but the magnitude of A, the magnitude of B, and sine theta, and there is a vector, unit vector, which is actually directed perpendicular to the plane containing the vector, perpendicular to the plane containing the vector. That means if you can say that is the direction of A, that is the direction of B, then n cap will be directed perpendicular to the plane. That means if we take this is a plane, then it is nothing but the perpendicular to the plane. So the thing is that that is nothing but A cross B. So if we say B cross A, if we say B cross A, then the direction will change. That means if this is A and this is B, if we do B cross A, then it should be directed like that. That means what we can say, that A cross B you cannot write as B cross A, whereas you can say A dot B you can write B dot A, because that both will give you the same result. But when we are dealing with the vector, since the directions of A cross B is not same as the directions of B cross A, so you cannot write A cross B is equals to B cross A. Now what will happen? So the formula is this. Now if we do, that means the formula is, you can say, is nothing but, if we do a vector product A cross B, it is nothing but the magnitude of A, magnitude of B, and this is nothing but the sine theta, and n cap. N cap is nothing but the directions which is perpendicular to the plane that is containing A and B. So if we now find I cross I, then what will happen? The angle between I cross I is 0. That means this is the magnitude of I, and the angle is, you can say, 0 degree. So angle sine 0 means 0, that means it is 0. That means that is the reverse of the, you can say, the dot product. That means J cross J is also 0, or you can say K cross K is also 0. But now if we consider I cross J, then what will happen? I cross J, that means what you can say, this is nothing but I, this is nothing but J, and this is a perpendicular direction, that is also K cap, because I cap means that is nothing but the unit vector along x directions, J cap means that is the unit vector along y directions. That means when you are finding the unit vector which is perpendicular to the plane, that is nothing but the z, that means the, you can say, here the n cap is K cap. So what we can say, I cap magnitude J cap, and the angle is sine 90, because I and J, this is the x axis, this is the y axis directions, and they are perpendicular, and n cap is nothing but, you can say, K cap. So what is the result? Magnitude of I cap is 1, because we know unit vector magnitude is 1, magnitude of J cap is also 1, sine 90 is also 1, and the K cap. So the answer is K cap. So what we get, if I cap plus cross J cap, that will give you result K cap. So if you can remember like that, say this is I cap, this is J cap, and this is K cap. If we move in that particular directions, what you can say, that I cap cross K cap is equals, J cap is equals to K cap, and again J cap cross, you can say, K cap can get you I cap. Similarly, K cap cross I cap, that means K cap cross I cap can give you J cap. So you can find that there. And the thing is, if we do J cap cross I cap, that means that will give you minus K cap. If we do K cap cross J cap, that means we are just reversing the thing, the result is minus. If we do I cap cross K cap, the result is minus J cap. But it will not occur when we are dealing with the dot product. We are dealing with the dot product. So now if we want to find the value of A cross B, like that in the previous case we also take this, that means we are taking AX I cap plus AY J cap plus AZ K cap, and say the vector B is nothing but BX I cap, BY J cap, and BZ K cap. Now if we do A cross B, it can be found by a technique. When you are finding the determinant, that is as the same technique, that means we are, say, this is I cap, this is J cap, and this is K cap, and we are just putting the coefficient of A, that is nothing but AX, this is AY, this is AZ, and this is nothing but BX, this is BY, and this is BZ. So the thing is that the result is like that, if we take I cap as a common, you just forget about I cap and you have to multiply this minus this. So that means AY BZ minus AZ BY. Now if we consider, say, you can say, if we consider J cap, we are taking minus sign. If we consider J cap, then you have to multiply. If we take minus sign, then you have to multiply with this minus this, that means you can say AX BZ minus this. So this is first one, AX minus BZ minus AZ BX, and if we take K cap, then it should be multiplied by, if we take k cap, then you forget about the k cap, and the thing is that what we can write, this ax would be multiplied with by and ay would be multiplied with bx. That means you can write ax by minus ay bx. So that you can say, you can do by using this. So this is you can say, if you want to find the magnitude of a cross b, that is the corresponding magnitude. That is same as that when you are finding the determinant. When you are finding the determinant, that is the one of the main thing that we should use. Now the thing is, another thing is that there is a resolution of vector. That means that is one of the thing, that the resolution of, you can say, vectors in rectangular, you can say, component. Rectangular component, that means resolution of vector in rectangular component. So the thing is that, if we can say that is the corresponding vector, this is a vector r and this is angle theta, then if we can break it into two parts, the theta part, actually that is nothing but r cos theta, and this perpendicular part, that is called r sin theta. That is the one of the important thing that you should know. That means if we say this is a, this a can be written as r cos theta, and if this is b, b can be written as r sin theta. That means when you are breaking this vector into two parts, the theta portions, the portions which is actually touches with the theta, that is the cos component, and which is perpendicular to this, that is called sine component. That means when you are breaking a vector into two parts, one part that is called, you can say, cos theta component, and another part that is called, you can say, sine theta component. That you should know. So I think up to this it is clear to you.
Yes, sir.
Okay. So do you have so you don't have any such confusions from that? Okay. So say a questions comes like that, then we will discuss one questions, then we will stop that. But the thing is that, say the question is like that, that what is the angle, the question is you have to find like that, what is the angle between, say, a 2n force and 3n force, so that their resultant, so that their, you can say, resultant is 4n. So what is the angle between a 2n force and 3n force, so the resultant is 4n? So if this type of questions are given, so what we know, the resultant formula is nothing but, that is p square plus q square plus 2pq cos theta. So they actually asked to find the value of theta, and what is given r, this is the resultant, that is 4 Newton is given, the p, that is 2 Newton is given, and q, that is 3 Newton is given. So if you just put the value, you will get, that means this is 2 square, that is 3 square, that is 2 into 2 into 3, that is cos theta, and you can see that the results that will come out, this is 4 plus 9, that means, you can say, this is 9, 13, that is 12 cos theta, and this is 16 if we whole square this, and this is 13 plus 12 cos theta. So you will find the value of cos theta, this is 3 by 12, so you can say 1 by 4, so theta you can write cos inverse 1 by 4. So this is the one type of problem that you should solve. So is it clear, the problem statement or the problem? I think there is no such problem. Okay. Okay, so the thing that we all covered, I think it is understandable to you, and the thing is that that is one of the